Exquisitely designed nanoparticles are revolutionizing how we're approaching health and wellness. For instance, by precisely engineering nanometer scale particles, scientists are beginning to explore how they can get essential vitamins into our body more effectively, or even to deliver therapeutic drugs more efficiently. Nanoscale drugs are an especially exciting area of research at the moment. By taking really powerful medicines and forming them into nanoparticles, we can get them to precisely where they need to be in the body. But for them to be effective, they have to evade the body's defense systems.
The major function of the human immune system is to protect us against foreign materials, and nanoparticles can be recognized as foreign materials and induce an immune response.
And what is it that determines whether a nanoparticle will trigger an immune response?
There are different parameters which are important for the induction of an immune response. It's the material, it's the surface, and it's the size.
So how can we design nano-sized drugs so that they evade the immune system?
We have seen that nanoparticles in a size range of about 50 to 100 nanometers and with a specific surface can induce more prominent immune reactions than others.
Understanding how to ensure nanoscale drugs do what they're designed to do without causing problems highlights both the opportunities and the risks of using nanotechnology in our bodies. Of course, many of us won't be experiencing nanotechnology-based medical treatments on a day-to-day basis. But nanometer-sized particles can and do get into our bodies in other ways. For decades now, nanoparticles have been added to food. Titanium dioxide, for instance, helps manufacturers achieve vibrant colors in everything from candy to cake topping. And silicon dioxide nanoparticles are used to stop spices and other powders from clogging up. Because we've been exposed to nanoscale particles like this for such a long time without any apparent side effects, it's been assumed that they're safe. But researchers are beginning to explore how they interact with our bodies just in case. Hans-Peter Nageli is one scientist who has been studying this as part of the NRP64 program. So you're studying silicon dioxide nanoparticles in the food we eat. What concerns you about these particles?
Some food items contain very high concentrations of silicon dioxide particles, and I believe that they may disrupt the normal function of the intestinal immune system.
So you've been studying these particles in systems outside the body. What have you found?
We found in our studies that silicon dioxide nanoparticles are able to induce an inflammatory reactions in our test cells.
Should we be concerned about this?
You should be worried only if you eat large amounts of convenience food really every day. We have to see now if these results that we obtained in the reaction tube has any relevance for the whole organism, like for animals like mice or rats, and also then for humans, of course.
Of course, to be harmful, nanoparticles not only need to be able to get into our bodies, they also need to get to places where they can cause serious damage. And one of those places that we probably don't want nanoparticles to get is the unborn child being carried by a pregnant woman. So when a pregnant woman gets toxic substances in her blood, what stops those substances crossing over and affecting the baby?
At the start of this project, not much was known about the transport of nanoparticles at the barrier. So for our studies, we use human placentas because it is very important, as the placenta is the most species-specific organ. We studied the transport of fluorescent polystyrene particles, and we have found that the transport is possible, but it's dependent on the size of the particles and also on the surface modifications. At least for these kind of particles, it has been shown like 550 nanometer particles could pass the placental barrier, while particles larger than 240 nanometers did not.
So how dangerous is it to the fetus if these really small nanoparticles can pass across the placenta and get into the fetus's blood?
Simply knowing that transfer does not yet imply that there's a risk for the fetus, so for this more studies need to be done on fetal models to understand if they are really toxic.
But it's not just our health that we need to be concerned about when it comes to nanomaterials. There's also the environment.